but please keep relaxed because my topic is very easy to understand. And I'm sorry I have to deliver this presentation in English. My English is not good, but my Japanese is worse. And I promise my English is very easy to understand. Okay. First of all, please allow me to briefly introduce myself. My name is Tetsu. I'm a second-year graduate student in Sasadan Laboratory in the University of Tokyo. And about my research activity, one is the memory profiler for Ruby, which I will talk here. And another is to convert Ruby to X10 programming language. Today, I'd like to talk about the memory profiler we created for Ruby. I will focus on the demonstration and the future of the memory profiler, and talk a little about the implementation and design. My talk will take about 20 minutes, and if you have any question, please don't hesitate to raise your hand up at any time. You can ask me a question in English or Japanese. Okay, let's get started. Well, we all know Ruby, and we use it to create different kinds of software, including some large-scale and long-running applications. For example, the web applications or some enterprise development. And we also know for this kind of development or software, it's very easy to suffer from some memory-related problem. For example, the memory leak or inefficiency memory usage. So we want to create a memory profiler for Ruby, and we expect it can be used to solve memory leak problem, and it can be used to provide hints for solving inefficiency memory usage, and it should be able to work in practical production environment. Okay, next I will give you a demonstration. In the demonstration, I will show you, you can see what the memory profile looks like and how we use it to solve a problem in the real world. The target of our profiling is RDoc 2.2. It's not the latest version, but I think it has been widely used. What you may not know is RDoc contains over 17,000 lines of code, so it's kind of big or complicated application. But what you may know is this version of RDoc suffers from some performance problem. If I run the RDoc to generate document for the entire lib directory on this environment, it will take about 50 minutes and use up to 1.3 gigabytes memory. So it's heavy and kind of slow. We want to find out what's wrong with it and try to optimize the performance. Next, I will show you the video. We set up RDoc and memory profiler on different PC, and we can attach the memory profiler to RDoc. Here the result show in real time, as you can see. In this view, we organize the result by the class. You can see we can show the number of instances and size, something like that, and the total memory. And we can show a dynamic graph to show the memory changes. And for each time of garbage collection, we create a pie chart to show what object is deallocated in it. So we run this profile for a while to observe the result, and please note the hash object. As you can see, the survival rate of hash object is very high. About 99% objects didn't deallocated during the garbage collection. And the number of live instances in the third column is keep increasing. And in the dynamic graph, we can see the tendency of the memory usage is keep increasing. So we guess if there is a memory leak problem, and it may be caused by the hash object. So next, we try to locate where the problem is. First, we detach the memory profiler and attach it again. This time, we will record the allocation call trace. I will explain it later. And here, if we click the hash object, you can see the object is created by which method and in which file, and the line number of it. It's a little hard to say, but 100% of hash object is created in this function called chain what into. And so we can check the code, we fix it, only 3 lines, and we run memory profile again to verify the result. This time we don't need the allocation call trace, so please focus on the hash object. And as you can see, the survival rate is reduced when garbage collection occurs, and the number of DB instances will reduce too. Oh, by the way, if you push the GC button on the toolbar, it will force the virtual machine to perform a kind of a garbage collection. And the dynamic graph shows that the memory usage is very stable. So once again, you can see the number of DB instances decreased. So we know we fix it. Thank you very much. And we measured the execution time and the amount of memory used by the RDoc before and after we fix. And here is the result. As you can see, after fix, the RDoc can run much faster and consume less memory. So only 3 lines of code. Okay. So, and another good news is for the RDoc 2.3 or later version, it doesn't have this memory leak problem. So the new version of RDoc can run as fast as and consume as less as memory as our fixed version. So you have choice to use a new version of RDoc or fix 3 lines of code. Okay, after you have a general idea about the memory profile, I will talk the main points in it. First of all, the memory profile can collect a lot of data from Ruby virtual machine, and I did see in this table. The data in green is what we use to debug the memory leak problem. And based on this data, we can create different analyze report for user. I will give you some example. In this, the data is organized by the class. So we can see the class name, the number of DB instance, the survival rate, and the size of it. Okay. Next one is allocation view. In it, it shows allocation call trace. Allocation call trace shows an instance is created by which method, and the stack trace or call trace of that method. And this output is constructed by aggregating allocation call trace of each instance. For example, you can see here the object of array is created by, for example, the each method. And each method is called by the times, and so on, and finally it will be the main method. And in each one, we can show the method name and the file it in and the line number of it. And we can also calculate how many number of instances is created by this method. And by the way, this output is inspired by the massive in Valgrind, which is a very famous heap profiler for C. And you may ask what is good for. First, it can be used to allocate the problem, as I showed in the demonstration. And the second, it can be used to detect the hotspot of object allocation. We can know which method created the most of the object. And the next is the dynamic graph to show the total memory used by the Ruby application. It's very easy. So, and the last one is a pie chart for garbage collection. We call it garbage statistics. It shows how many objects is deleted by garbage collection and what are they. For example, here over 29,000 objects is deleted by the second time of garbage collection, and among that, about 62% are string. Well, next, I will summarize some advanced feature of our proposed memory profiler. With this feature, I think the memory profiler is very easy to use and suitable for production environment. The most important feature, or what makes it different from other profiler, is it can monitor Ruby applications. And there are 4 sub-features to make it possible. The first one is memory profiler can analyze the profiling result in online or offline model. As you saw in the demonstration, the profiling result is shown immediately when it attached to the RDoc in the real time while RDoc is running. We call it online model. And of course, you can save the profiling result to somewhere and to analyze it later, and we call it offline model. And the second feature is the memory profiler can be attached to or detached from the target application at any time during the execution without interrupting the execution. And when the memory profiler is detached, the overhead of profiling is 0. So we can profile on demand to get a result when you want and detach it when you don't feel it's necessary. And third is the memory profiler is able to profile either local or remote applications. As you see in the demonstration, RDoc run in a different PC. And the last one, user can choose what data they want to gather from the memory profiler. So we can control the overhead. Okay, after you have seen what the memory profiler looks like and what it can do and how we can use it, next I'd like to explain how we design and implement it. First of all is some design principles. I think the most important thing for a memory profiler is to keep the impact to the target Ruby VM process as small as possible. It means the memory profiler should use small heap size to store data on the target VM process and has small CPU stress on the target VM process. And moreover, we require the memory profiler should be easy to change. For example, we want to add some new output format. It should be easy to done. So I think the high modularity is required. So in consequence, I don't think in-process memory profiler is a good design. And we attempt to satisfy both of these 2 design principles using following architecture. This graph shows the architecture of our memory profiler. It is divided into 4 parts. First is modification on the Ruby virtual machine. It opens an interface to expose some internal status of Ruby. And second is the blue box in the middle. We call it backend. It is responsible for collecting data from Ruby virtual machine. And the communication channel defines how to transport the data from backend to the front end. And the green box shows the front end, which is a user and application to create analyze report for user. The good thing for this architecture is we can push heavy job to the front end. We don't care how many memory it will be used, how many CPU time it will consume, because it runs in a different process, even on a different PC. But the bad thing is data transfer have some overhead. By the way, if you're familiar with Java, you can know we borrow this architecture from JVM2 interface. And last, I will talk about the implementation. I won't bother you with details, but I will give you a quick overview. To put it simple, we modified the Ruby virtual machine. We create a backend as a C extension, and we use some native thread to make it run parallel with the Ruby virtual machine. And we implemented the communication channel over socket, so we can use it over network. And the front end is implemented using Java Swing library as an example. Of course, you can use what your favorite GUI library to implement it. And consider to the modification on the Ruby virtual machine, there are 3 parts. First one is we add 4 events to get information. The new object, delete object, garbage collection start, garbage collection stop. And we also implement a stack iterator to get the allocation call trees from Ruby virtual machine. And we define a new method to get the actual size of an object, especially for the customized object. Okay, I think I have covered everything I want to say here. And finally, I will give a quick summary over the main point of my presentation. In this presentation, I present the memory profiler we created for Ruby. It can gather a lot of data. And I argued that the memory profiler is easy to use and suitable for production environment. And I give you a demonstration. In it, you see the memory profiler is suitable, is very useful for debugging memory leak problem. So in conclusion, I'd like to say we developed a useful memory profiler for Ruby. Okay, that's all. Thank you very much for your good attention. Any questions?
Martin Dust, Ayamagakuin University. This is very impressive. Maybe I missed that, but is it available already, or do you plan to make it available, and what timeline or how?
You mean when will it will be available?
I want to use it.
Oh, very well.
Probably others also want to use it.
Thank you very much. In fact, the problem is we made some modify to the Ruby virtual machine, but I can't commit to Ruby trunk right now. But I will, and Sasada will help me to do that. And the best bet is in Ruby 9.3, 1.9.3. You can get this feature. Okay, thank you very much. Any other questions?
Same question? Yeah, everyone wants to use it. Okay. So, any other questions?
日本語で失礼します。
はい
フロントエンドとバックエンドのコミュニケーションでオーバーヘッドが大きいという話ですけれども、そこってどれくらいのインパクトがあるんでしょう？
はい、そうですね。The impact is depend on the size of the data the data need to be transported between backend and front end. For the worst case, if we record every data we can get in the backend to the front end over a network, it will slow down the application by 10 times. And if the best case, if we only we only get we don't connect the allocation cartridge, and over the network, it will slow down the application by about 3 times. So, do I need to say it again in Japanese? そういう質問確認ですが、データトランスファーの影響はどのぐらいあるかどうか聞いてるんですよね。はい。もし全部データ、allocation cartridge を含めて全部データを転送する場合は10倍遅くなります。もし、allocation cartridge を抜いて、大体3倍ぐらい遅くなります。はい。
ありがとうございます。
ゆぐいと言います。On IRC, Nowset said you should put it on GitHub. I think so.
Okay. Thank you.
I once write a dtrace patch for Ruby,
Yes.
and I want to know where you put your callbacks on Ruby. Where you put callbacks on.
Oh, okay. Sorry, I can't show the code right now, but we tried very hard to make the fix of Ruby as small as possible. In fact, right now we put the callback at 4 points, and for the object new, I put the callback at the function allocate object from heap, I guess. And for garbage start and stop, I put it in the garbage collection method. And for the delete object callback, it put in garbage collection method too. And I will make a patch for you so you can check the code. Okay, thank you.
It sounds good. Please publish it on GitHub.
Okay.
Good talk. Have you given any thought to the communication channel between the profiler back end and front end? This is something that comes up in debugging and profiling over and over again. In terms of, you have events, they have to get communicated. You use, for example, TCP/IP channel, but
Yes.
it could be, people will say, well, I want SSL, I want SSH encryption, I want serial PT, I want serial line. But all of these things have sort of a common problem, which is that, sometimes maybe the front end may want to say, ooh, stop, enough. So the question is, have you given any thought to that, to separating the communication channel part, so that other kinds of, not memory profiler, maybe it's speed profiler, maybe it's debugger profiler, and I'll just say that the only thing that I know of right now, and the only thing I know of right now is something called DBX that was done by Active State and somebody in Zend in PHP. That's the only thing only effort that I know of, that I'm aware of, where people made an effort to standardize the remote communication protocol. Okay, but anyway, have you given thought? Are you aware of anything else? How easy is it to to change the profiler front end. Okay?
So you suggest me to open the definition of the communication protocol so user can do what they want.
Yes, but in part of doing that, and an equal and important other step is opening is using a standard interface for the communication channel, so that not just your memory profiler, but maybe a space profiler, maybe a debugger, maybe I don't know what. Okay, there are many applications that want to attach to a process and get events back.
Yes. Okay. Thank you very much for your comment. And in fact, one reason we employ this architecture is that I think it is very flexible. So you can use different language to create different parts. For example, the backend is written in C, and the protocol, the communication channel is implemented using Google Buffer protocol, and the front end is written in Java. So it's separated. So right now we don't have a very stable interface about the communication channel protocol, but I think we can fix it so user can customize the front end as what they want. And consider to the back end, right now, student in Saturn Laboratory is also working on a CPU profiler. I think the backend can be reused. So the best bet for the future is Ruby user can have a all-in-one profiler. They can run CPU profiler, they can run debugger, they can run memory profiler, all use this architecture. That's what I try to advocate it, and that's the best bet I can do. Okay, thank you.
Any other one last question? Okay.
ネットワーク応用通信研究所の中村です。Ruby のトランクでちょっと GC が変わってる感じなんですけど、はい、その辺になんか対応するとか、そういう対応する必要があれば対応する必要があったりするんでしょうか。あと対応する必要があるとしたら、対応する気はあるんでしょうか。
Did you understand?
Sorry, but
the question was the Ruby GC is somewhat different than other languages, so
そういう質問はこれからの RubyGC は変わりますので、メモプロファイルとしては対応しますかどうかですよね。はい、対応します。はい、しないとコミットもらえないかな。はい、ありがとうございます。
Okay, and so I want to close the session, so thank you.